Hello, my name is Ben Nussbaum. Today I will be speaking about knowledge graphs and the journey to the connected enterprise and what that means for all of you. I have about 20 years of software architecture, design, and implementation experience. The last 10 focused specifically on globally distributed solutions for large enterprises, and the last 5 focusing around connected data solutions. I'm speaking from a hands-on practitioner perspective where I'm being tasked with designing, implementing knowledge graph type solutions. First off, these are charts. They're not graphs. If you thought these were graphs, it's because you've been lied to your whole life, and they're not graphs. To understand what a graph is, we need to take a look into the past, back to the 1700s, and examine the work of Leonhard Euler. He was a Swiss mathematician, engineer, etc., who is responsible for much of our modern day mathematics, including graph theory. These are graphs. He lived in Königsberg, and there was an interesting arrangement of the land there. There were 7 bridges connecting these different land masses, and the question arose, was it possible to cross all 7 bridges only once? And as he pondered that, he developed much of the graph theory notation and representation for how to work with connected data. And as you can see here, we have things and their connections. We have the land masses, which are kind of the nodes, and the bridges are the edges that go between them. Now, to make this useful from a data storage perspective, as a knowledge graph, we need to enrich these with a way to store properties and other metadata about the nodes and edges, or the relationships. More recently, in building on that work, Google and Facebook, who each have, Google has their knowledge graph, Facebook has their social graph, they've seen the value and leveraged this very well, what you can do when you understand connections, how the world's connected, how things are connected. Those are important. Much of the rising popularity today in the graph database space and what is making it possible for an organization to even have their own individual knowledge graph that is truly a native graph based on the principles in graph theory is owed to the work done by Neo-technology, which for the last 15 years has been developing Neo4j, and they've been in production for, I'd say, over a decade at this point, with different enterprise customers. It's by far the most popular graph database out there and the most widely used. So you should definitely check that one out. They've done a really phenomenal job in just advancing the space. When it comes to our data, there's 3 things we really want. We want it to be intuitive. We want organization top to bottom to be able to work with our data, to understand it, to talk about it, know the business concepts, know how our organization functions, works, what's important to it, what are the metrics, what are the data points, what do we have, how do we leverage that as a business asset. We want to be able to do that quickly. If I have to wait days or hours or even minutes for a batch process, sometimes that's too long. In the world we live in today where you pull to refresh and it's few MS, you start to want all of your operations to be like that, even back office, ad hoc analytics. You're forming a query, you're trying to understand some nuances about your sales, your manufacturing, how things are connected with your customers, what they're going to buy this spring. You want that to be instant so you can get your result, iterate, try again, adjust, and be able to do things much more in real time. And then lastly, we need it to be flexible. We need that agility that as our business needs change, as the organization changes, that we can really have our data adjust with that in an easy way. Not through complex data migrations that take days or weeks, but simply by saying, okay, we now need to add this additional property and store that. We can start doing that going forward. Or we can add this other thing and connect it in to where it belongs with the rest of the nodes and relationships that we have and continue forward from there. And if we need to make any adjustments to the other data structures, we can do that because the graph is flexible. It's not a rigid structure like a table. A table has a certain predefined set of rows and columns. The graph is not like that. Decades ago, data used to be stored like this, stored on a punch cards. Not very easy to see cross-references, not able to update, very inflexible, challenging to work with. As an improvement, we started storing it like this. Fits into the rows, columns. It's probably what most of you are used to. We have SQL today. The challenge here is that as we go through our data, we end up with many join operations because these are all index-based. So if I need to connect something over here to other things, it needs to be joined together. And if I need to do that multiple times across multiple levels, across an entire organization, it becomes a very large, time-consuming process. So we throw many machines at it, we distribute it, but we still have our data in a disconnected state with just weak foreign key references. It's just simply an ID number. There's no context, no relevant connectivity about why these things are connected in the way that they are. But now, we can store data like this. It's in a graph format, where our nodes are our things, those are the circles that you see, and the lines are the edges, and those are the context of how things are related. But why does this make sense? Well, your data is actually connected like this. Data is a representation of the world we live in, and the world we live in is connected. I process and experience the world I live in based on how I'm connected to the things around me, the people in my life, the restaurants I eat at, the movies I watch. To start dealing with data in that way, let's look at a couple examples of how the data you have today is actually a graph. Starting with identity and access management. This was actually my first introduction experience to graph databases. We were building a solution for a company in Los Angeles in the media space, and we were using MySQL to try to model and represent this complex media asset management workflow, and just dealing with all of the controls, the different groups, the organizations, multiple vendors that were involved, who was a part of which group and what they had access to and could sign off on, and all the permission structure. It was just getting really slow and out of control because it was a very large system with many different types of users, roles, groups, permissions, etc. And what we started to see was that the function of identity and access, it's not really about my role in an organization anymore. It's really about my function on a specific team or group, how I'm related to that group and what I should have access to. Just because I'm the sysadmin doesn't mean I get global access to read, write, do anything all the time. If I'm working with another group in the organization and I'm simply advising or providing insight, I maybe should have read-only, etc. So the structure of how this graph looks, how this data looks, is changing, and it needs a structure that enables that in a very real-time manner. In some scenarios, to onboard a new user into a typical identity and access management control system could take days. just to get everything propagated out and actually apply that. In a graph, it's a matter of drawing the relationships, and it could just take seconds. Graph-based search. The text that you type into the search bar is really just one component. There are many things that can be done to enrich search as you type that text. And that is a lot of what Google has seen, and that's why they built the knowledge graph. And that's a lot of what Facebook sees when you search on Facebook. They have the whole social component. So there's this context of the connectedness of you as an individual. When you're searching, knowing that context, knowing the context of the documents and what they're related to, it enriches and enables better search results. Master data management. Master data management is about mastering your data. Most enterprises have many different sources, and if we have, let's say, 5 different databases that all have customer data in them, well, we want to be able to create one kind of connected customer view, have that single representation of John, and basically be able to say, here's John, these are the orders that he bought, these are the ones he's returned, this is what he said on social media about what he likes, etc. We want to be able to bring all of those together. The thing about graphs is they provide a flexible schema, which allows us to create many subgraphs. I like to think about them as layers. I can layer in all my different sources, bring them into the graph, keep them up to date, manage them individually. And then to create that kind of source of truth, mastered data that all of the applications will work with, we simply connect back to those sources and say, okay, this is my source for this person. This is my source person. We've done our matching, we've run our cleansing, etc., and we've determined that these are the same people. So now I have John and I have all the source Johns that exist as well. They're all in the graph, can all be introspected, and can be updated. But now I have my single representation of John, and I can update all my sources individually. And this works because each individual data source may have different properties for a person. And in the graph with a flexible schema, I can still refer to all of these persons as a person and say, conceptually, this is a person. Even if you have a different set of properties than this other data source that we brought in that also has the concept of a person. And then we can process them and work on them together within the connected graph. Fraud detection is a really interesting one, especially in the financial space. Fraudsters have gotten much more sophisticated. They do not create individual accounts that look out of bounds. They create rings, networks of many accounts that are all within normal range, so they don't send off any individual flags. But when you look at them together as a whole and do that network analysis, which graphs are great at, detecting patterns within data, then you can very easily see and even detect in real time and prevent these types of fraudulent activities. Another way that fraudsters do this is with synthetic identities. Those are basically taking this person's name, this other person's address, this other person's social security number, mixing them together and creating a new identity from that. Well, in the graph, it becomes very obvious, and what you see here is that there's multiple people using the same social security number, same address. They're sharing pieces of information that normally wouldn't be shared, and so it becomes very quick and easy to detect that fraud is being committed. Network and IT operations. Your network is a graph. All of your connected components within that network, from your switches to your routers to the laptops that are on that, all a graph. So if you're a network and IT or a telecommunication company and you want to actually do network simulation or analysis for, okay, we're going to take this device out, how do we represent that? Make sure that we don't disrupt traffic flow. What are the paths that are blocked by this one device? Or we have a failure, we need to respond. You can do that path analysis. So going from one part of your nodes through the graph to another, because they're all connected, is a very quick, constant time operation doing those traversals through the graph. There are no join operations necessary with a native graph database. Cyber threat detection kind of builds on the network and IT operations. You're simply looking at the traffic coming into your network. What are the requests doing? What pieces of infrastructure are they trying to access? And how do we look at those patterns of use and detect threats against the network? Your data connected is your knowledge graph. All of the data across your enterprise, when it sits in its silos, does not really provide you good business value. But when you bring it and connect it, then you have a valuable business asset. That is your knowledge graph. That is the foundation for learning, understanding, even machine learning, artificial intelligence, to work from as a holistic perspective of your enterprise. What are the benefits of a knowledge graph? Why would we want this? Some of the main ones are that you're interacting with your data in its true form, because your data is connected in this way. Your data is meant to represent the world we live in, and the world is connected. I think some of the big ones are everyone can understand the data across the organization, up and down the organizational structure. Everybody understands relationships. We all interact with relationships every day. We have our friends, we have our colleagues, our loved ones. Maybe those are some in the same. But from technical to business to marketing to product, all of us can talk about these concepts because our data and how it's connected are the business concepts that are important to model and represent for the organization to move forward together holistically. If manufacturing data never gets exposed to customer data and connected across those silos with the financials and marketing, and they don't talk and work together, everybody's moving forward in isolation. And that leaves gaps for the organization. Connected data is very intuitive. In doing all of trainings with different enterprises around the world, as well as training our own engineers that work on these connected data solutions, developers will get more done in less time. When you're dealing with data in a form that doesn't really fit the data, such as tabular, rows and columns, you're dealing with tables, it doesn't really fit the data well. So there's a lot of things you end up doing to massage it and try and get it to do what you want. You end up normalizing the data, denormalizing the data, and it just wastes the developer's time. When it's intuitive, you can focus on solving the problem. So with all of this, by having this data connected, you have understanding across the organization, and an organization that's working more efficiently. First, diving into that improved data understanding. Working in tables is a lot like this shelf of different index cards. You have to go pull something out, look at its reference, go get what it's referenced to, pull it out again. And as a developer, that's very draining, very tiring. You're just thinking about joining. How do I go get this thing and go get this other thing and join them together? And it can just consume you and really create a grind that takes a lot of time. But when your data looks like this, and this is what's actually stored in a native graph database, and this is how you interact with it. When your data looks like this in its connected format, it's very intuitive. You can look at it and see, oh, I have a user who looked at this product, and other users looked at this product, and we have these other products that they've also looked at, or maybe they bought, and this product is in this category, and there's these other products. Well, so now we can start to think and reason and say, oh, okay, well, if you're looking at these products and you're interested in this and these other people were interested in this, well, I could recommend that you look at these as well because they actually purchased these and we want to try to convert you and get you to buy things. But I should also look at your social media that we have from you, different touch points that we've had, email campaigns, things you've responded to, what you've been interested in. Have you returned any of these products? Because I probably don't want to recommend you something you've returned already. What have you bought already? I don't want to recommend that. I also don't want to recommend things that we can't actually deliver based on our inventory. So in this way, this graph, this connected view of the data tells a story that's very intuitive. And when you start thinking in that way, as an organization and as a developer, you get a lot more understanding from it. It also really improves your cross-functional collaboration. Many times in the past 15 years of working with SQL, I've gone into organizations, had conversations with the business folks, tried to understand the concepts, and then when it comes to actually building the database, designing the database, and solving the problem that I'm being asked to solve, you'll disappear into a room, come up with your third normal form, normalize all the data, separate out all your tables, figure out the attributes, how you're going to join everything back together, put it into that structure, bring it back, talk through it with them. Inevitably, the eyes glaze over, and they don't really understand. And even if they say they do and they sign off on it, then you go build it. And then you start to see 6 months later that, oh, well, this concept doesn't really work exactly this way, and now we need to do data migrations, etc., etc. And that's because largely we're not working on that data model together because there's this technical barrier. And we want to get past that technical barrier, and graphs enable us to do that. With graphs, I've never had as much success talking from top of the business side, marketing, down through the sysadmins and technical. Everybody can understand this. And the beauty of it, graphs are super whiteboard friendly. You can literally stand in a room and we can talk about your business concepts. And I can draw them out on the whiteboard. And we'll say, okay, so we've got this customer. And they buy things. They buy this product. And we'll map out the entire set of your data, how it's connected, these business concepts, what are important to your organization. And through that, we can all look at that and have the subject matter experts on marketing or on the product side or manufacturing that understand exactly how they work, and they can contribute to that model. And then once we all look at it and agree this is how our data is actually structured and how it works, then we can go take it and put it into the graph, and it will stay in exactly that format. So there's no room for misunderstandings, miscommunication. It will go in exactly in that way. And so in this way, graphs connect not only your data, but your whole organization. On the developer productivity, there's an example that I want to show. This is actually a real comparison of a complex SQL join versus a native graph query. The query language that you're seeing in this native graph query is called Cypher. It's a native query language for graphs. You can check it out on opencypher.org. It provides a declarative pattern matching syntax that is representative of connected data. In this example, we're looking at a hierarchy for the reporting chain, so how you go up that chain. In Cypher, it's actually a simple depth-based search. Because there are no joins in a native graph database, we're not afraid of depth. I can go 10 levels deep, I can go 100 levels deep, I can go 1,000 levels deep. Friend of a friend of a friend forever. And I don't have to be worried about ballooning index operations because there is no join. I'll talk about index-free adjacency later. But in this example right here, the star 0.3 essentially says match the boss and go look at 3 levels of his subordinates. Then look at all of those subordinates and who they report to. And then return that as the total reporting count. How many reports does this person manage and have in their hierarchy? Simple, concise, designed for native graph operations. That's why it's important to be sympathetic to the graph and connected data. Let's take a look at a few of the key components of a native graph database. The main elements that you're working with within a graph are your nodes, which are the things in your data, your relationships, which is the context of how two things are related. And it's important to choose a native graph database that treats relationships as first-class entities. A relationship should always have a starting node and an ending node. Labels are essentially tags within your graph. They are applied to nodes, and a node can have one or more labels. And they're a way to organize your graph into sets of nodes that can be targeted for specific queries or certain operations, such as a person. I could label a node as a person. I could also label them as an actor. Properties. One of the most important elements in a graph, and the enhancement from just nodes and edges that Leonard Euler had, is the property graph model. It's really important to be able to have properties on both your nodes and your relationships, because this is where you'll store the data and how you'll use it as an actual database. Here we're looking at a sample of a graph. We have a person, which is your node, and we have the label person. So that node is a conceptual representation. It's an entity within the database, and it has properties, it has relationships connected to it, and it has labels associated with it that tell you what it's been tagged as. Then we have our relationships. This is the edge between two nodes, and it has a specific type. That's the context of how it's connected. So here we can see this person prefers this hotel that has available rooms. And then properties. Maybe this person node has a property name, Jane Smith, and prefers, also has a last stayed timestamp, so we know when they last stayed at this hotel. And the name of the hotel is Hilton. And then the room number that's available is 315. And in this, we can see that it speaks very much like English, and it should. When you're modeling, you should be able to say, this person prefers this hotel that has available rooms. I can talk through the graph. Very intuitive, yet very powerful in how it represents the data. The question that we want to answer today is, how do we go from big data to smart data? I've seen over the last few years that there's been this kind of big data deluge where everybody's been focused on getting data, amass it, store it, put it on disk. And many enterprises have done that. Some are just getting over that, where they're like, great, we just got Hadoop implemented. This is fantastic. We're putting a lot of data down, writing a billion rows a day into our data warehouse. This is great. And yet, the question remains, what would we do with it? Now that we have the data, what do we do with it? And that's the problem that many enterprises are just realizing. Big data did not address that. The big data promise left a lot of enterprises unsatisfied because it just resulted in a lot of infrastructure, churning in a lot of data, but not really leveraging it as a business asset. And I think that's where knowledge graphs will really make the difference for the enterprise. Knowledge graphs will take all that data ingest that happens, get it into a connected state across all those silos that we just talked about, and enable discovery, reasoning, recommendations, real-time interactions, without needing to go back to the data warehouse for large exports into memory, waiting. It'll provide a tremendous competitive advantage to your organization, and it will be the future. Every organization in the next 5 to 10 years will have a knowledge graph powering their enterprise, because they see that understanding end-to-end, holistically, the organization and all of its data and what drives it will be necessary to compete. Graph thinking is a paradigm shift. It really is different. It's not just putting a graphy layer that's visually different on a relational database or on a SQL database. It's a shift in how you think about data organization, data storage, data retrieval. It goes top to bottom as an enterprise. When you start embracing the graph paradigm, you'll find that you unlock incredible possibility. This paradigm has never made more sense to me. After spending 15 years in the relational world dealing with tables, and I got the taste of a graph structure and what it enabled, what I could do, the complex problems I could solve seemingly with ease, it was almost like a drug where you're like, I need more of this. I want everything as a graph. I just need to solve them all with graph problems. There are very few, if any, problems in the world today where connected data does not provide a significant advantage. First of all, this is how the brain works. Our brain deals in patterns, connections, what we're connected to. So the graph is intuitive to the brain because that's how our brain functions. Thinking in tables is not intuitive. It's not how the brain processes data or organizes its own data. We can solve more complex problems with much less effort. If any of you have ever tried to solve shortest path in a relational database, I'm sorry. I'll just apologize for all relational databases everywhere. Very sorry. Not a fun experience. I hope you've never had to do it. Sorry if you have. With graph, being able to take two nodes from that graph and say, show me the shortest path between them, is a built-in function on a native graph database. A truly native graph database can do that with ease, and it'll come back sub-second, very fast. You can use any of the algorithms from graph theory, and this is where graph theory really comes into play when it's at a core database level within the graph, because you have A-star, Dijkstra, all these algorithms that deal with traversing through the graph, looking for patterns in the graph. All of those are at your fingertips and can be leveraged. Clustering algorithms, centrality algorithms. You have a whole suite of mathematics available to you that you can now leverage with ease because your data is stored in a true graph structure. Improved collaboration between technical folks and everyone else. This is a key point of the paradigm when it comes to organization efficiency as a whole. If your technical folks can talk to your marketing and business folks and everybody understands what they're talking about, you will move forward faster and with less error. And you'll move forward together. And I think flexibility is a big one too. Business changes. Your business is not the same today as it was yesterday, as 5 years ago, and it won't be the same tomorrow. You need a database that allows you to evolve with that change with ease without needing to worry about massive data migrations. I know of scenarios where with certain large SQL deployments that if you were to add, because of the depth of the number of rows, if you were to add one more column to it, it's not even feasible because it wouldn't finish in our lifetime. How does that make sense for your data storage? With a graph, because it's not a rigid table structure, you can at some point say, okay, going forward, all persons are now going to have this other property as well. We know we need it. Maybe the US creates some new ID system to identify everybody outside of social security number. And now every person in the US needs to have this. And you're like, okay, great. We'll start doing that going forward from this date. Everybody before that didn't have it. Doesn't matter. If they're still alive, they'll get it, right? So that flexibility is important. A new paradigm requires a new engine. This is really important, and I can't stress this enough. There are many non-native graph databases out there today, as the space has gotten popular and evolved, there have been many databases and companies that have said, oh, me too, we do graph. But it really, there's a few things you need to look for. Putting a graph layer on top of an SQL database or a document or a tabular, key value, etc. database engine with an abstraction layer that just gives you the feeling of doing graphy things, that's not a graph database, because your underlying storage engine is not designed for connected data. You still have tables, you still have columns, you still have documents. Those aren't truly graph databases, and they will come back to bite you if you choose that for your implementation, because they are not sympathetic to the nature of reading and writing connected data. It's a new paradigm. You have to be sympathetic to what does it mean to read and write connected data, where you're not updating one record but two records, especially if you're writing a relationship, where you always have two nodes that are impacted by that relationship, because those nodes will always agree on the relationship between them. Things that a native graph database has that you should look for: needs to be optimized for graph traversal. Cannot simply be just part of that, like an edge cache or a specification for connected data. Needs to be graph traversal. I can go from one node to the next, general graph traversal. How do I go through this and do that efficiently without indexes? Relationships need to be first-class citizens. If you don't make relationships first-class citizens in the graph database you choose, your knowledge graph will be limited, because you won't have that rich contextual connection between the two. Referential integrity. This is an important one, a little more technical, but it's key to understand. It speaks primarily to the guarantee that two nodes will always agree on the relationship between them, which means that when you update a relationship, you need to guarantee that those two nodes agree on that. You're not updating a single record, a single document with some ID that references another relationship. This relationship is a first-class entity. It knows both its nodes, and it's going to always update together and keep those nodes agreeing on that connection between them. For example, Ben works for Adam Rain. If at some point Ben is fired from Adam Rain, in a non-native graph database, it would be possible that the record for on Adam Rain's perspective that they fired Ben gets updated to show that. But on my side, I still think I work there, so I keep showing up for work. Well, that's no good. That's why you want a native graph database, so the two node records always agree on the relationship between them. And then lastly, when you're looking at a knowledge graph, and it's going to be your source of truth for your learning, your understanding, your core business operations, you want it to be ACID compliant and fully transactional, so that as your applications read and write data and you start writing and using that as your primary interaction point for all of your applications, that you get that same level of data integrity that you've come to expect from your relational databases today. Using a non-native graph is really like keeping your old dirt bike engine for your new race car. You just end up doing a lot of pushing. So don't be afraid to embrace a native graph engine. Choosing your engine is a big decision, and you want to do it carefully. Really, in the market today, there's only one leading native graph database engine, and that's Neo4j. There are many non-native and not graph databases that get thrown around, and I understand it's confusing because the space has gotten really hot over the last couple of years, and there's a lot of Me Too's showing up and a lot of confusion if you're not deep in the space. So some of the other ones are RDF. It's a specification put out by W3C. There are some attempted databases that do the triple store, but it's not really built around graph traversal and the notion of doing that traversal in a constant time. Tinkerpop is a compute framework. So there's a difference between data storage that's a native graph database and a compute layer. A compute layer isn't really a graph database, although they get promoted as graph databases. They're just a compute layer. FlockDB is an edge cache. It's built by Twitter. Primarily put out to handle their millions of follow relationships. All of these people following everybody else. It's not really a native graph database. It's an edge cache, even though it's called a graph database. So graph database, that label gets applied to a lot of things, but they're not. And then some non-native graph databases are just Elastic, DataStax, IBM. They've put graph layers on top of existing columnar, document, etc. data stores. So that's why you want to be careful in choosing your engine. If you want a truly native graph database that gives you constant time operations as you traverse the graph, you'll want to, along with the data integrity and all the benefits we just discussed, you'll want to go with Neo4j. They're the leading native graph database engine for a reason. They've built it to be optimal for graph traversal, treating relationships as first-class citizens, being ACID compliant and fully transactional. They're my go-to for enterprise knowledge graph solutions, connected data solutions. But not just me, they're used by over 50 of the global 2,000. The leading enterprises in the world are finding tremendous competitive advantages by using Neo4j. If you choose them, it will accelerate your knowledge graph initiatives because it's very intuitive, very developer-friendly, very easy for an organization to adopt. How do we integrate this with your existing architecture? That's always an important question from the enterprise software perspective, because you guys have a lot of existing architecture. So we need a very low-risk, non-invasive way to do this. And the way that we do it is we create connectors. So if you've got Oracle, DB2, Hadoop, etc., go ahead and create a connector to get data out and start flowing it into your connected data, into your graph, into that model, that representation. So we flow it into the knowledge graph. So now we've got all of these sources feeding into the graph. And then we connect our real-time analytics, learning, understanding, etc. applications. They interact with that native graph database directly. And then as this data flows in, you want to make sure that it's being written properly. And that's where the ACID compliant nature and referential integrity guarantee is important. Because as you have this data that's just constantly streaming in from your other data sources, and as you have applications writing in real time to it and starting to use that as its source of truth, with that new data flowing in directly, you want to make sure that it's giving you that same level of integrity that your existing databases do. This is one example of what that non-invasive architecture could look like. If you have an end user using an application, and that application has access to relational NoSQL Hadoop databases, and day one, that's all it's using, well then you introduce your native graph database into the mix, connect it up to those relational databases, and start flowing data into the connected form. Your application can be updated to consume and use and interact in for real time with the native graph database. And then eventually, your new applications will use only the native graph database. Same way with your bulk analytics infrastructure for your internal data scientists, business analysts, etc. You can start flowing that data into the connected graph, which your data scientists will enjoy querying. Cypher is actually a fun language. I do trainings in Los Angeles, and I can teach a data scientist or business analyst to be comfortable with their own Cypher queries in about a day. So in a one-day training, they'll be comfortable running ad hoc queries. It's a very intuitive language. And that'll save them a lot of time in getting the real-time interaction, doing their analysis, and being able to visualize and see the connections, see those patterns and those paths, provides a whole different way of looking at data that they'll appreciate and that will become more apparent of how things are working and where potential business value lies in that data. And so in the same way, we just consume from that data warehouse infrastructure. Where do you go from here? You need to embrace the paradigm shift. Go native make sure you get a native graph database. Get connected, flow all your data into it, get it connected. Start working intuitively as an organization, top to bottom. Break down those barriers between the technical and the non-technical folks, and transform your organization. And be a leader in your space. Thank you.